This chapter describes the procedure and common problems of the OTDR test. Tools and materials used for the test include the OTDR tester, test fiber, dust-free paper, and alcohol. Now let's introduce the preparations for the test. Clean the end surface of the test fiber. Use a piece of dust-free paper dipped in alcohol to wipe the end of the connector 2 to 3 times. Connect the 2 test fibers using an adapter. Clean the end of the FC connector, which is connected to the OTDR port. Test fiber connect OTDR. The teeth of the test fiber connection OTDR connector should be aligned with the slot of the OTDR output port. Fasten the cables after they are properly installed. Click the OTDR mark on the tester's display. Set parameters. Set the transmission distance, pulse width, and average duration. For details about how to set parameters, see the setting principles. Set the refractive index wavelength provided by the optical cable manufacturer. Select the wavelength again. The tester machine used this time supports 2 wavelengths, 1310 nm and 1550 nm. And this time we choose 1550 nm. Start the test. Find the serial number of the optical fiber to be tested on the ODF. Connect the OTDR to the optical port. Click on the OTDR tester to start the average luminescence. After the test is completed, save the information such as the optical fiber start and end point, fiber serial number, and other information. Use the same method to test the remaining optical fibers. Edit and save the test results. Press the measurement icon on the top of the screen to move the AB cursor. Move A cursor to the straighter starting point of the fiber under Test in the curve. Move B cursor to the end of the line segment to the left of the end reflection peak. The attenuation per kilometer is displayed in the lower right corner of the screen. The following is an analysis of the abnormal curve. 1. The curve has a big gap. This may be caused by the fiber being squeezed at the big step, or it is because of the optical fiber coil is too small, or the fusion splicing quality is poor. 2. The big angle may be caused by poor fiber quality and high attenuation, or the optical cable is too tight. The optical cable fiber is not long enough. 3. No reflection peak at the far end of the optical fiber. The possible cause is that the fiber may be broken, or the end is not clean, or it's damaged. The phantom or ghost appears on the curve because the measured optical fiber is short, or there are multiple mechanical connectors on the link and they are close to each other. The method for dealing with this problem is to decrease the optical power or increase the attenuation at the end. 5. Positive gain occurs when the optical fiber after the splicing point is larger than the optical fiber before the splicing point, generating more backscattering scattered light. It is often found at the fusion splicing points of the fibers with different mode field diameters or backscattering coefficients. Actually, the splicing point has loss. Generally, the value is obtained using the bidirectional average method. 6. The slope of the normal curve is smaller and uniform. The curve is straight. No abnormality exists. The splicing point is not large, and the step has no reflection peak. Common errors in the OTDR test. 1. The test fiber ends connected to the OTDR are not cleaned with dust-free paper dipped in alcohol. 2. The teeth of the test fiber connector are not aligned with the slots of the OTDR light-emitting port. 3. The connector of the test fiber is not tightened after being installed on the OTDR light-emitting port. 4. The test fiber is not fully connected to the accessive fiber and there is a gap between them. 5. The test fiber may be damaged. 6. There's dust in the live connection V's. 7. No oil is placed in the V of the live connection. 8. The end of the live connections are defective and irregular.